Good morning, students. So today we begin with scan design. Now, important thing about scan design is basically we are talking about DFT, that is design for testability. In short, we call it DFT. So now we will begin this design for testability. As the name suggests, design for testability simply means that you have to redesign your circuit so that the circuit becomes testable. Redesign in the sense, अभी हमने क्या पढ़ा है, कॉम्बिनेशनल और सीक्वेंशियल लॉजिक पढ़ा है. तो अगर कुछ मुझे एप्लीकेशन बनाना है, से एक एडर बनाना है, so I use the logic gates, AND gate, XOR gate, OR gate. These gates are used, simply connected. Sequential के लिए I have the D flip flop. I connect these components together to form my circuit. But now there may be some lines which are difficult to test. For example, uska controllability is infinity, or observability is 0. Observability is infinity. So it means that particular line will not be controllable or observable. So now we need to modify the design or modify the components so that every line becomes testable. कॉम्बिनेशनल सर्किट में तो कोई दिक्कत ही नहीं है, थोड़ा कॉम्प्लेक्स हो सकता है बट नॉट अ प्रॉब्लम. The problem comes when the sequential circuits are included, when D flip-flop is included, because we are not able to control the secondary outputs and the secondary inputs to these flip-flops directly. So now the main idea for a DFT or a design for testability is to obtain controllability and observability for the flip-flops, so that these flip-flops can be represented in the form of some combinational circuit, and we can apply ATPG for the combinational circuit, which is very easy. One time cycle में ही testing हो जाती है, because we are able to determine the test patterns, right? So for that we have different options. You modify your components or you modify your circuit completely. One option is by adding a test mode to the circuit, right, which is called design for test. Means आपका circuit जो है वो अलग work कर रहा है, and when I want to test it, I have a dedicated line for, or a dedicated setting for testing to be performed. Testing के लिए I can apply these lines directly. So I use a test mode to the circuit other than the actual working mode, right? So that when the circuit is used in test mode, all the flip-flops functionally form one or more shift register, which we call the scan registers, right? So that if there are multiple D flip-flops, they are now converted into a simple register, चाहे वो combinational circuit में कहीं भी connected हो. So in test mode, जब हमें testing करनी है, the flip-flops can be controlled by giving some input and then shifting that input in multiple D flip-flops, right? So that this becomes a shift register. So एक input दिया, उसको shift किया, उसको shift किया. So I am able to control the values. Also, I'll be observing these values easily. Okay? Certain rules that we need to have D flip-flop only. All the D flip-flop will be governed with a single clock, synchronized होने चाहिए. जो clock है, that should not be giving the input to any D flip-flop. The clock must not feed data input of flip-flop. It should be a primary input. It should not be a secondary input or a secondary output. Okay? And there is at least one primary input which is available for test, so that I put my pattern inside this shift register. So for that, the first option is that to a general D flip-flop जिसमें एक input था, एक output था और clock था, I add two more input lines. The first input line is set, the other input line is reset, which can directly be used to put some value on Q. As per the table that is shown here, if set is 1, reset is 0, then I expect my output to be 1 irrespective of my input. Input is don't care, D is don't care, but the output is set. Similarly, if the reset is 1, if reset is 1, the output should be reset to 0 irrespective of my input, also irrespective of the clock in both the cases. Right? However, I should not be anytime giving set equal to 1, reset equal to 1. This becomes illegal. But if both the values are 0, it means the circuit is not working in test mode and it is working according to the input. So these can be analyzed for inputs. Right? So agar mera set or reset dono 0 hai, then whatever is my input D is seen at output Q, a normal D flip flop working to at clock edge. So यहाँ पे मेरे पास एक normal D flip flop मिलेगा और यहाँ पर D flip flop is not working like a normal D flip flop, but I can set the values directly using set and reset. The problem that we see with this method or this technique is, suppose we had this circuit. ये मेरे पास पिछला जो circuit है हमने analyze किया था, the same circuit. Now I add a set and a reset line to each of the flip flop. Let us say this is level 1 flip flop. So S1 R1 is added here, S2 R2 is added here, set and reset line. So 3 तो मेरे primary inputs हो गए. उसके अलावा अब मेरे पास additional 4 inputs are required to be controlled. ठीक है? These also become my inputs. So the number of input will be very, very high if I consider any general practical circuit. अभी तो केवल 2 ही flip flop है तो 4 inputs बढ़े. अगर मेरे पास n flip flop है, so the total number of inputs are increased by 4n, where n is quite a large number when it comes to the practical circuits. Right? Each D flip flop represents 1 bit. तो हमारे पास अभी तो प्रोसेसर ही 64 बिट के हैं. So the number of bits is very, very high. So the number of flip flops will be increased and hence the number of control input. तो चीज तो अच्छी है कि set और reset line दे दो so that जब test मुझे करना है, so I say I put this set 1 0 and I can set the value as 1 directly. Time frames की जरूरत नहीं पड़ेगी. एक बार में ही मैंने यहाँ पे वैल्यू इक्वल टू 1 सेट कर दिया. सो C becomes X, A और B की पर्टिकुलर वैल्यू होगी एंड द वैल्यू कैन बी प्रोपोगेटेड टू द सर्किट इनसाइड. राइट? लेकिन इशू इज द मोर नंबर ऑफ इनपुट्स. द सॉल्यूशन टू दैट इज अ स्कैन रजिस्टर which is nowadays used. Scan register means एक normal flip flop है which is now referred to as non-scan register and we add a mux to it. This is a multiplexer which is added before this input D, where the control signal is referred to as TC. If TC is 0, if test mode or we say if TC is 0, then the data is selected, the data line is selected, right? Data line is propagated. If TC is 1, the test mode is selected and I provide the input through SD, which is called scan data. This is called scan data because the data that I provide here will now be used in the shift registers. All the flip flops will be connected as a shift register and I can pass on these values. Right? उल्टा हो गया. TC equal to 0 is scan and TC equal to 1 is the data mode. So if TC equal to 0, this line is selected If TC equal to 1, this line is selected. If I simply construct this mux with the help of logic gates, the construction is something like this. And this is D, TC, NOT gate, and here I have scan data. So if TC is 0, then the output of the upper AND gate will be 0, and this will be depending upon my SC. Right, so this SC will be propagated because the other input is set to the non-controlling value of 1. If TC equal to 1, means यहाँ पर 1 आएगा, यहाँ पर 0 आएगा. So now the input is set to non-controlling value for the upper AND gate, and whatever the data I have, that will be transmitted. Right. So this multiplexer will be implemented as a circuit which has 4 gates added to my circuit basically. एक flip flop पर 4 gate additional लगेंगे. But the advantage that I get here is, suppose there is a combinational logic and there are 3 scan flip-flops, 3 normal flip-flops were there. I converted them to a scan flip-flop. Scan flip-flop kaise? The output of the first flip-flop is given as input to the second. The output of second is given as input to the third. The output of the third is read here, so that all the connections are seen in series. Right? Scan flip-flop के लिए input कौन-कौन से होने चाहिए? Scan data, control signal TC and D. So D तो ये आ रहा किसी भी combinational circuit से. This is the actual data that I should receive from the combinational circuit. I should write D here. ये black lines तो मेरी हो गई data lines. I have given a control signal TC to each flip-flop. So these gray lines are TC. If TC is 0, scan करो. अगर TC equal to 1 है तो data transmit करो. ठीक है? Data individual flip-flop में आ रहा है. लेकिन अगर TC equal to 0 है, then I provide some scanning data through these brown lines. This brown line becomes input to first flip-flop only. So that whatever I give here, that is given to this first flip-flop. At the next clock edge, this gets propagated to second flip-flop. At the next clock edge, this gets propagated to the third flip-flop, and I can read it at the output. So shift register की तरह काम कर रहा है मेरे flip-flops. Right? Something like this. ये एक normal circuit है. Combinational circuit से कुछ outputs आ रहे हैं which are given as line D. I add a multiplexer with the control signal and the scan data. This scan data is generally the sequence 00110 011. This pattern keeps on repeating. Why so? If I choose this pattern, scan in हो रहा है मतलब shift register में entries हो रही है. So the value of the first flip-flop is initially 0. Then at the next clock edge, another 0 is pushed in. So any change in the output from 0 to 0 means 0 सही से pass हो रहा है या नहीं, that is confirmed. The next third bit would be 1. So now the output has to change to 1. So is the flip-flop able to shift the change, able to see the change from 0 to 1? This will be confirmed. अगर error free है तो 1 आ जाएगा, error है तो 0 आ जाएगा. It means the flip-flop is not working properly. Now the fourth bit will be 1. So if it is 1, then it is testing whether the flip-flop is able to pass continuous ones or not. If it is able to pass, then fine. The next bit will be 0. So now I'll be testing my flip-flop for a transition from 1 to 0. So all the 4 possible transitions, 0 to 0, 0 to 1, 1 to 1, 1 to 0. These will be tested if I apply this as my scan input. So I need not change the scan input every time. I do not need to do an exercise to find out a test pattern which I should give at scanning. This becomes fixed. That is the advantage that I get. I do not have any more PIs added to my circuit as compared to the previous case, जहाँ पे मुझे set और reset lines add करने थे. हर flip flop पे 2 inputs add करने थे. This is not the case here. No more additional inputs except for 2. जो भी fixed है. TC is either 0 or 1 or scan in is 0011, 0011 and so on. That is the advantage of adding the scan registers to my design. Is it clear? Now, how the test is carried out for the scan circuits. This is the scan register which is used within my circuit. I represent the complete circuit with the help of some combinational logic only. And the inputs are divided into 2 parts. This is the normal test pattern which is used for testing. So this is data mode, the input for data mode, and this is the scan input. Right? Which of the 2 inputs should be applied depends upon TC, the control signal. Fine. So now I have 2 phases for testing any circuit. First phase, that I should test for shift operation of the scan registers. अगर मेरे scan registers सही से shift कर रहे हैं, in that case, if data is given into it, the possibility of error is not there. Therefore, the first phase will be testing the scan chain, that is your scan register or the shift register, and then test to normal testing for combinational circuit, stuck at fault for combinational circuit by applying the test patterns. Right? So how do we work for it? Initially, I should work with test phase 1. So I need to ensure that the scan data is provided at input. So initially TC is 0. जैसे ही test 0 हुआ, it means the scan data is provided. So I start putting in scan data 0011, 0011, that data that is started to put in. How many cycles do I work for? I work for n number of cycles, where n is number of flip-flops. So if I consider 9 flip-flops in my circuit, I should give TC 9 times so that the first data has reached the last flip-flop. Right? यहाँ पे मैंने पहला bit दिया से 0. That 0 is shifted to second flip-flop, third flip-flop, fourth, fifth, sixth, seventh, eighth, ninth तक आ गया. So it is all my circuit or all my flip-flops are tested for passing on data. Right? So scan test हो गया. During the time my scan data is provided, the primary inputs are don't care. ये जो gray region है, this simply represents don't care. So since I am using in test mode, the circuit is working in test mode, the primary data is 0 or don't care. I do not worry about this primary input. Fine. Now, when I have verified that all the flip-flops are working properly as shift register, I need to check for combinational circuit. So for combinational circuit, I will apply TC equal TC equal to 1 होते ही scan data becomes don't care. Right? test vector I1 is given parallelly for all the primary inputs. I am giving a test serially input कर रहे हैं, ठीक है. So I am giving this parallel input I1. Now when the first provide the shifting, I will again test for shifting before I try for second. I provide my second vector. Similarly, for the third test vector, I'll do the same cycle again. What happens towards out? For the output will be observed in two parts. N1 will be the output corresponding to scan. अगर मेरा पहला bit मैंने 0 दिया, I expect my be seen here. Oh, the data is string, right? 9th flip flop तक data shift हो गया है, लेकिन अभी मैंने read कुछ नहीं किया है. Therefore, this is all don't care. The scan out for 9 plus 1 10th clock is don't care. ठीक है. उसके बाद मेरा N1 pattern आना शुरू होगा. Those bits will be read now after the 10th clock cycle, because at 10th clock cycle I have provided the input pattern I1. Corresponding to I1, I should expect an output O1, right? So the cycle ends here. Fine. Now N1 will be seen at output, and the output due to the primary inputs become don't care. I'm not worried about this because I am simply testing the output of the scan register. It should come out as 0011 00110, right? So the first scan output is analyzed 10 cycles later. ठीक है. उसके बाद वापस से मेरा TC equal to 1 हो गया है. So I have applied my input test pattern I2. Corresponding to I2, O2 will be generated. The output at output for the combinational circuit, right? During this time, the output due to scan data will be don't care. In the next cycle, when whatever data that has been set in the flip-flops during this time, that data will be analyzed here. Serially, that data will be analyzed here. Right? जब analysis हो रहा है, उसी के parallel में I am shifting my data inside the scan register as well. I am providing input sequence S3, but detecting the output sequence N2, so that जो data save हुआ था वो अब read हो जाए. Then again I have one clock cycle which is dedicated for I3, the third test pattern, for which I will generate O3 and I'll test for O3, or the faults which are detected using I3, वो detect हो रहे हैं या नहीं, these are observable or not. And the pattern which I have inserted during this time, S3, will then be detected afterwards. But definitely the number of input lines is reduced, the complexity is reduced, nothing more is added except for the two control line and scan data input. Is the working clear? When we consider this circuit, I consider two more inputs such that this is scan-in line and this is my TC. TC is a single output which is given over here for all the flip-flops. I set TC equal to 0, flip-flop work in this Q becomes directly connected to D. Your TC becomes the control signal and the data keeps on shifting between the flip-flops. This is called scan design. This scan design is very important when we need to test the boards. The reason being, जब हम boards बना रहे हैं तो इसमें multiple circuits are combined together. Multiple, in fact, ICs are joined together to form a particular big processor. So all those ICs may be working with different sizes, may be working with different nomenclature, but every time we need to have something done so that all are considered together. So when we are testing for boards, we are using this scan chain design as boundary scan. I check the outputs and input compatibility using the scan chain. Okay? Any problem in this? That is all for today. We'll continue with the circuit and the use in the boundary scan in the next class so that we finish in the next class. Any problem in today's class?
मैम लास्ट वाला पोर्शन एक बार और बताएंगे, पीछे वाला
कौन सा वाला?
जहाँ पे हम वो ले रहे थे इनपुट 1 इनपुट 0 करके ले रहे थे.
Testing part. This one?
Yes ma'am.
All the gray region shown here represents don't care. So what I'm basically doing is I'm trying to test my circuit in two parts. The first part will be testing for the scan कि shift register सही से work कर रहा है या नहीं, D flip flops work कर रहे हैं या नहीं. So for that what I do is I initialize my circuit with TC equal to 0. जैसे ही TC equal to 0 होगा, my circuit is set in scan mode या test mode. So that now I give my scan in, that is this S1. Scan in क्या है? Toggle sequence है 00110011 of particular length. कितना length होगा? That is अभी हमारे पास 9 flip flops हैं. So 9 clock cycles के लिए मुझे ये data देना है. Here it is written, it is NSFF, that is N is number of scan flip flops plus 4. Because 4 बार मुझे ये input देना है, then the output will be your one flip flop will be tested for all the possible cases. 0 से 0, 0 से 1, 1 से 1 and 1 से 0. So minimum मुझे 4 cycles चाहिए to test one flip flop. Right? So total number of cycles will be N plus 4. So here what I am doing is यहाँ पे मेरे पास 9 फ्लिप फ्लॉप्स है. सो 9 बार मैंने TC दिया, TC इक्वल टू 0 सेट किया है, सो दैट आई प्रोवाइड माई इनपुट एज 0011 0011 0. This data is now set in my 9 flip flops. पहला बिट जो 0 दिया था that is shifted from first flip flop to the 9th flip flop. हर किसी में अब डेटा हो गया है. Right? Now I need to test for output of this. तो वापस मुझे 9 cycles चाहिएंगी. So better output यहीं के यहीं check करने से I provide my test pattern as input, test vector for combinational circuit testing at input. So I put TC equal to 1. TC equal to 1 means I provide my primary inputs. The data is already set, already checked for scanning. कि आपका registers properly work कर रहे हैं, इसका मतलब D flip flop properly work कर रहा है. So पहला test pattern I have applied here. जब मैंने ये टेस्ट पैटर्न अप्लाई किया तो इसके करस्पॉन्डिंग एक आउटपुट जनरेट होगा फॉर माय कॉम्बिनेशनल सर्किट. सो आई सिंपली चेक इफ द रिक्वायर्ड आउटपुट इज अचीव्ड और नॉट. कहीं कोई फॉल्ट अगर एग्जिस्ट कर रहा है देन इट विल बी डिटेक्टेड बाय अ फॉल्टी वैल्यू इन O1. कोई भी स्टक एट फॉल्ट हम एनालाइज कर सकते हैं. ठीक है. नाउ सिंस एट दिस टाइम द इनपुट पैटर्न I1 is being analyzed, so the scan output is still don't care. I have not read any output from the scan register. I have simply put values at the D flip-flop. When I put it to 0, now I again start to put in the scan data. 0 1 ठीक. तो अब जो मैंने पहला 0 सीरियली आउट आएगा, तो सबसे पहले ये वाला 0 आउटपुट आएगा, फिर इसके बाद ये 0 आएगा. अगर मेरा स्कैन चेन प्रॉपर्ली वर्क कर रहा है, शिफ्टिंग विल कम आउट प्रॉपर्ली. द डेटा विल बी रेड एज 0 1 1 0 0 1 1 0 0, जो यहाँ पर इनपुट दिया था. And I provide another set of same input here. Scan data fix ही रहेगा, यही sequence रहता है, right? तो अब मेरा scan data is tested at output. Now I can say that all my D flip-flops are working or observed. All my outputs are observed at the primary output, right? But during this time, since I am testing for scan data, the output from the combinational circuit, the primary output should be don't care. Then I apply the second test pattern. Multiple test pattern will always be required, right? Multiple test patterns हमने देखा ही है. जब भी D flip flop कोई भी combinational circuit मुझे analyze करना है, I1 test for certain n number of faults, then the next m number of faults will be tested using I2 and so on. So I may have different test patterns. So I am applying those test patterns in between. For every time I am applying I1, I2, I3, I am observing the output of the combinational circuit. Okay. So since 3 inputs are analyzed here, 3 test patterns, I1, I2, I3, this will be completed in 4 sequences, because the final data S3 at input scan data will be read at sequence 4. Every time I am testing that flip-flops have not made an error, so that I ensure कि flip-flop की वजह से ये O2 में error नहीं है. ठीक है, यहाँ पे अगर मेरा scan data सही आ गया है, इसका मतलब flip-flops are working properly and there is no error, no fault due to the working of D flip-flop. अगर यहाँ पे fault आ रहा है, that is only due to stuck at fault in the combinational circuit. Therefore, I have an extra thing, that is I have one sequence to be run extra, so that I have to generate the all, so that I check for all the outputs O1, O2, O3 with the scan data. ठीक है, दोनों simultaneously चलाएंगे हम. The input test pattern and the scan data. ठीक है. We'll solve a numerical based on the use of this scan register, but it will take time, so it will not complete today. So I'll do it in the next class only, so that we finish and we start and finish with the analysis in one class. This is all from Bushnell, but the chapter title is Design for Test. It is not with the name of scan registers, but the chapter is Design for Test. Okay. Anything else?
No, ma'am.
Okay. On Saturday, you have the quiz for ATPG for sequential and combinational circuits at 12 o'clock.
Saturday or Sunday?
Sunday. Last time also we had the quiz on Sunday 12, na? So today, this time also Sunday at 12.
Okay, ma'am.
And please start studying, because everything is numerical, and your midterm paper will be completely based on long questions. So the marking may be less, but process तो पूरा ही करना पड़ेगा. So you need to practice those methods. For the quiz also, you will have at least 1 or 2 questions which will require you to work in pen and paper, so that you answer those questions. So, or not all the questions will be for 1 mark only. There will be questions for more than 1 mark as well. Okay? Okay. So that is all for today. I am ending the meeting. You may leave.